Hi, we are the group Pathfinder. I'm Ziming Li.
I'm Jun Ma.
I'm Xiaoning Wang.
And this year we are joined the DTU RoboCup competition because we are very interested in this and we want to know by our knowledge how many tasks we can challenge on the track. And we also want to see some advanced robots such as the robot with the balance system, and some of them are using image processing technology with camera, and some of them are using the mechanical arms. And it's really exciting competition, and we also got a lot of good experience from this. We used a lot of knowledge we have learned in TVP4E from last semester in doing this robot, such as timer, PWM, and AD converter setting in the processor, SPI communication in between the two controllers, and control series. And we have also put some new things in this robot. For example, the robot we have built for TVP4E is one core system processing all the data. The other core is used for repacking and sending data to Bluetooth module. It won't influence robot when it's running on the track. But in this robot, we have two cores to process the different data at the same time. One core processes the data from all the sensors. The other one processes all the data from the motors. And they are using SPI to communicate. Now I will introduce the details of the robot. First, I would like to introduce this small circuit connect between the sensor control circuit and the 3 distance sensors. It's used to increase the power pins come from the sensor control circuit and apply the power to the 3 distance sensors individually. This layer of the circuit combines our sensor controller and optical sensor comparators. These potmeters can adjust our optical sensors comparators compare value. And this is the SPI programming part. Here is the switch power for our robot. It's the power connection pins. We add a big decoupling capacitor to decrease the noise coming from the batteries. Here is the reset button to reset our sensor controller. And this button is used to start our robot. Now I want to introduce our base. It's our motor control circuit. Here you can see it's our motor controller. And these are the shift registers and external counters. It's the reset button to reset our motor controllers. And from the back side, you can see here is the edge bridge, and here is the peel. We use the peel to control our motors going with the different direction or fast stop. These two red LEDs are speed down or stop indicators, and the white one is going backward indicator. On the left side, here is a part. It's our SPI programming part for the motor controller. In the front, the two power LEDs are our power indicators for our base. Because we are using SPI both at communication and programming, so we need to disconnect the two cores when downloading program to one of the process. That's why we build a small board with a big switch. At the bottom of our robot, here is our optical sensor circuit. As you can see, there are 8 optical sensors. In the school, we have 2 types of the optical sensors. They are OPB742 and OPP745. For the OPP745, it's a used Darlington transistors, so the response of it is big, more or less like a digital signals. But for OPP742, it's just use the normal transistors. It's more linear, like analog signal. That's why we choose the OPP742 as our sensors. We also made two frames. One is in the front of our optic sensor circuit to protect our sensors when it's going down from the stairs. And another one is at the back outside of our robot to protect our base when the robot is going down from the stair. Because we want our robot go through the two skiddles in the competition, the distance between the two skiddles is 25 centimeters, and the minimal distance which sensor can detect is 10 centimeters. If we put our sensor at the side of our robot, it's too close to the skiddle, so the sensors cannot detect the distance. That's why we built a frame to fix our three distance sensors in the middle of our robot. To challenge this competition, we have done lots of similar tests in school, and we almost solved all the tasks on the simulation track. But when we test our robot on the real track, we meet some new troubles, such as the tails are not flat, and also the space between the tails could influence the voltage of the optical sensors. So we add oversampling in the program and decrease the height of the sensors to get better result. Sometimes we make our robot go in a short way to skip the tails. We also made some changes on the wheels to make them more soft. Because the fraction of two motors are not the same, when the robot goes down the incline, it always goes to one side. Then we clean the bearing of the motors. Finally, it works good. The last and also the hardest challenge is the night skiddles. The shape of the skiddles are round. The size of them are not the same as the one we have in school. So at beginning, when we try to use one distance sensor to find the location to make the robot go through the skiddles, it's very unstable. By a lot of testing, we found that we could use two of them or all distance sensors to do double or triple check. Afterwards, the result is much better than before. By doing all of these works, we found that if you want to be successful, when you get problem, you need to discuss with your group members, think, test, and insist doing it. Finally, you will make it. For the next year, if we have time to participate in this competition again, we would like to do some changes on our robot, such as to find some better optical sensors, and if it's possible, we would like to add an image process and mechanical arms on our robot. That's all what we have done in this semester. Hopefully you enjoy it.